Unit 2, Segments, Lines, and Angles. Preview video 2.2, Part 2, Segments on a Coordinate Plane. Sit tall, pull your chin up, deep breath, inhale. Hold your breath. Slowly You're right here. We're continuing our focus on segments on a coordinate plane. Don't forget date, time, location, and a parent affirmation sign-off. There are three motions that we need to be able to handle on a coordinate plane, segments. And these skills are you need to be able to find the middle of a segment on a plane, find the tilt of a segment on a plane, and find the length of the segment on the plane. Last class, we did both middle and tilt. Let's say and write the midpoint equation 3 times. What are we saying? We're saying this right here. You're saying and writing at the same time. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. Slope formula. What we're saying is right here. Slope is rise over run, subtract the y's over subtract the x's. Slope is rise over run, subtract the y's over subtract the x's. Slope is rise over run, subtract the y's over subtract the x's. This class, we're going to talk about distance. Distance. Your distance equation is a variation of the Pythagorean theorem. I'm not going to get in too much detail, but you guys are familiar with this equation right here. The distance equation is basically solving for that C segment. Solving for that C segment, commonly known as the hypotenuse. So watch, I'm going to switch it around, and we have C equals the square root of A squared plus B squared. That's how these are related. The distance equation is a variation of the Pythagorean theorem. This is what we're going to say as we write it 3 times. The distance equation is giant square root, subtract the x's squared plus subtract the y's squared. The distance equation is giant square root, subtract the x's squared plus subtract the y's squared. Distance is giant square root, subtract the x's squared, subtract the y's squared. That's the distance equation. Let me show you how we're going to use it. Now, if I ask for the distance equation, that's what you write. If I ask for the distance template, It's the equation minuses the x and the y's. Super important you learn how to use templates. Let me explain on this problem. We're going to find the distance here between these 2 points. So negative 5, 3 is right here. Positive 1, negative 5 is right here. We start by writing a distance template, what looks like this. Circle box plug chuck. We're going to circle the x's, connect with an arrow left to right, and we're going to plunk the x's into the equation left to right. Box the y's, arrow left to right. And when you solve, you get the answer is 10. Now, it does not matter whether you go left to right or right to left initially. What does matter is if you start left to right, you finish left to right. Let's go the other direction, and then you will see that it's the same thing. So here, I'm going to redo the equation over the grid, but we're going to go right to left. So in this case, right to left, I'm going to go 1 minus negative 5, 1 minus negative 5, parentheses squared. And then I'm going to go this way, negative 5 minus 3, parentheses squared. If I solve here, double negative makes a positive, so this ends up being 6 squared plus, this is negative 8 squared. 6 squared is 36, negative 8 times negative 8 is positive 64, which is a square root of 100, which is 10. So you can see it doesn't matter whether you start left to right or right to left. What does matter is whatever direction you start with, you finish. So now we're going to find the distance between these 2 points. So we're finding the distance between these 2 points. What is the length here? Start by drawing a blank template. I circle my x's. I'm going from left to right. I box my y's. I'm going from left to right. Double negative makes a positive, so this ends up being negative 2 squared. Double negative here makes a positive. This ends up being 12 squared. Negative 2 times negative 2 is 4. This is 144. And so square root of 148. Now, there's 2 versions of the answer here. There's something called the exact term and then the approximate term. The exact term is preferred in mathematics. So the exact term would be to take the 148 and to simplify the radical. So in this case, there's a pair of 2's. So the exact distance would be 2 root 37. That's called exact. The approximate is where you put it in a calculator. Now, the approximate, which is a decimal, is not as accurate as simplifying the radical. You need to be familiar with both, however. So here we have 148, and we're going to find the square root. So the approximate, we'll take it to the second decimal, is 12.17. The approximately is 12.17. So what you need to know is shoving things in a calculator is not the ultimately accurate answer. The ultimately accurate answer here is what's called the exact form. Decimals are an approximation. Take 1 minute and verbally review the content of this lesson.